With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, in this question evaluate this integration limit 1 to 16 tan inverse root x minus 1 dx. Guys, consider it equal to I. So I is equal to integration from 1 to 16 over here tan inverse root x minus 1 dx. Now guys, consider x is equal to u square. Now differentiate both sides. So over here dx is equal to 2u du. Now let's we substitute these values. So over here I is equal to, let's we change these limits. So when x is equal to 1, then u would be also 1. So over here 1. So when x is equal to 16, then u would be 4. So over here 4 tan inverse in root at place of x. When you put u square, you will get over here u minus 1, and at place of this dx 2u du. Okay, now right, let's we simplify it further. So now consider u is equal to secant square theta. Differentiate both sides. So you will get du equal to 2 secant square theta tan theta. Okay, so let's we substitute these values. So over here I is equal to integration, let's we change these limits. So when u is equal to 1, then theta would be 0. When u is equal to 4, then theta would be pi upon 3. Over here tan inverse, over here at place of u we will write secant square theta. So secant square theta minus 1 is equal to tan square theta. So over here tan square theta 2u, at place of u we will write this secant square theta, and at place of this du let's we write this. So 2 secant square theta tan theta, and over here d theta also. Okay, now let's we simplify it once more. So y is equal to 0 to pi upon 3. Over here tan inverse, here we will get tan theta. Here 2 times 2 is 4. So 4 over here at place of secant square theta, let's we write over here 1 plus tan square theta. Over here secant square theta tan theta, over here d theta. Okay, now this tan inverse tan theta is equal to theta. So over here I is equal to 4 times integration from 0 to pi upon 3. Over here we get theta 1 plus tan square theta, over here secant square theta, and over here tan theta d theta. Now guys, consider tan theta is equal to x. Now let's we differentiate both sides. So over here we get secant square theta d theta is equal to dx. Okay, now so guys, over here I is equal to 4. Now let's we change limits. So when theta is equal to 0, then x would be also equal to 0, and when theta is equal to pi upon 3, then x would be root 3. Over here at place of theta, from this expression we can write tan inverse x. So over here 1 plus, at place of this tan theta we will write x, so it becomes x square. So over here secant square theta d theta, it is equal to dx. So write over dx, and over here tan theta is equal to x. So over here x. Okay, now guys, let's we simplify once time more. So over here we can write this whole expression as limit from 0 to root 3 4 tan inverse x, over here multiply x, plus 4 tan inverse x, over here x cube, and over here let's we close this, and over here dx. Okay, now let's we separate this term and this term. So over here we get I is equal to integration from 0 to root 3 4 tan inverse x over here dx, plus integration from 0 to root 3 this 4 as it is, and over here tan inverse x multiply x cube dx. Okay, now guys, consider this part as I1 and this part as I2. Now let's we solve this I1. So I1 is equal to integration from 0 to root 3 over here tan inverse x dx. Now guys, we will solve it using Eilert method. So consider it as u and this one as v. So over here I1 is equal to, we will write this u function as it is. So tan inverse x and integration of this second function. So x square upon 2 over here, limit from 0 to root 3 minus integration of differentiation of this first function, which is 1 upon 1 plus x square over here, integration of second function, which is x square upon 2 over here dx. Now guys, let's we simplify it further. So over here I1 is equal to, let's we apply these limits. So over here tan inverse root 3, which is equal to pi upon 3 multiply this root 3 square, which is 3, or over here upon 2. Now minus, when you apply this 0 limits, then you will get over here 0. Let's we write over here 0 and close this bracket, minus over here integration from 0 to root 3 over here 1 upon 2 here x square upon 1 plus x square. Now let's we add 1 and subtract 1 over here dx. Now let's we simplify further. So over here I1 is equal to, this 3 cancel with this 3, in bracket we get pi upon 2 minus 1 upon 2 integration from 0 to root 3 over here x square plus 1 upon 1 plus x square dx minus integration from 0 to root 3 over here. Due to this minus, it becomes plus, and over here we get 1 upon 1 plus x square over here dx. Okay, now let's we find out the integration of this function and this function. So over here guys, 1 plus x square and 1 plus x square, this cancel with each other, and over here I1 is equal to pi upon 2 minus 1 upon 2 over here we get only dx. So integration of this dx is x. So over here x limit from 0 to root 3 over here plus integration of this 1 upon 1 plus x square is tan inverse x and limit from 0 to root 3. Okay, now over here I1 is equal to pi upon 2 minus over here guys 1 upon 2. Guys, this 1 upon 2 we have to write over here also. Okay, so let's we write this one over here also. Now when you apply limit, so you will get over here root 3 minus 0, and over here plus 1 upon 2 over here in bracket tan inverse root 3 minus tan inverse 0. Okay, now let's we simplify it further. So I1 is equal to pi upon 2 minus, when you simplify it you will get root 3 upon 2 over here, and over here plus root inverse tan inverse root 3 is equal to, as we know that, pi upon 3, and over here minus 0, which is not need to write. Okay, now let's we simplify it further. So over here I1 is equal to pi upon 2, this one is pi upon 6, so let's we write over here pi upon 6 minus root 3 upon 2. So guys, when we simplify this term and this term, we get over here 2 pi upon 3 minus over here root 3 upon 2. So guys, this one is our I1 part. Now let's we find out I2 part. So over here I2 is equal to integration from 0 to root 3 tan inverse x over here x cube over here dx. Now guys, we will solve it also using Eilert method. So consider this function as u and this function as v. So over here I2 is equal to, over here we will write this u function as it is, so tan inverse x and integration of this x cube, which is x raised to the power 4 upon 4 limit from 0 to root 3 minus integration differentiation of this first function, which is 1 upon 1 plus x square, and integration of this v function, which is x4 upon 4 over here dx. Okay, now let's we simplify it further. So over here guys, let's we write 0 to root 3 limit over here. So now I2 is equal to, now let's we apply this limit. So over here tan inverse root 3 is equal to pi upon 3 dot, over here you will get 9 upon 4 minus 0, which is not need to write, but let's we write over here. Okay, over here minus, now guys we can write this whole expression as 0 to root 3 over here, and over here 1 upon 4 x raised to the power 4 upon 1 plus x square over here dx. So let's simplify it further. So I2 is equal to, in bracket guys, this 9 is 3 times 3, so over here we get 1, and over here 3. So we get over here 3 pi upon 4 minus over here 1 upon 4 in bracket integration from 0 to root 3. Over here we can write this x raised to the power 4 as x raised to the power 2 raised to the power 2. Over here let's we subtract 1 and add 1. So over here in denominator 1 plus x square dx. Okay, now let's we simplify it further. So over here I2 is equal to 3 pi upon 4 minus 1 upon 4 in bracket limit from 0 to root 3. Over here we get x square minus 1 and x square plus 1 upon 1 plus x square. Over here plus 1 upon 1 plus x square dx. Okay, now let's we simplify it further. So guys, over here I2 is equal to 3 pi upon 4 minus 1 upon 4 in bracket. Guys, this 1 plus x square is cancel with this 1 plus x square. Over here we get only x square minus 1. So over here guys, integration of this x square minus 1 is x cube upon 3 minus x. Over here plus integration of this 1 upon 1 plus x square is tan inverse x. Now guys, let's we apply limits on these functions. So over here 0 to root 3 now. So over here I2 is equal to 3 pi upon 4 minus 1 upon 4 in bracket. So when you put root 3 at place of x, so over here you will get root 3 minus over here root 3 plus over here tan inverse root 3 is equal to pi upon 3 and minus. So guys, when you put 0, so you will get whole terms 0, so not need to write. So over here we get only these 3 terms only. Okay, so over here I2 is equal to 3 pi upon 4 minus this root 3 cancel with this root 3, so we get over here pi upon 4 3 the 12 now. So guys, when you take LCM you will get over here I2 is equal to, this becomes 9 pi upon 12. So 9 pi minus pi is 8 pi upon 12. So when you simplify it you will get over here 2 pi upon 3. So guys, this one is our I2. So guys, our I was equal to 4 times I1 and plus 4 times I2. So let's we put value of I1 and I2. So over here I is equal to, let's we take 4 common. So over here I1 is 2 pi upon 3 minus root 3 upon 2 and I2 is equal to 2 pi plus 3, 2 pi upon 3. So over here 2 pi upon 3. Okay, so over here guys, this 2 pi upon 3 and this 2 pi upon 3, so it becomes 4 pi upon 3. So over here 4 pi upon 3 minus root 3 upon 2 over here in bracket and outside it this 4. So I is equal to this one. Now over here when you multiply 4, so you will get over here 16 pi upon 3 minus over here this 2 times 2 is 4, so it becomes 2 root 3. So guys, this one is our final answer. Thank you guys for watching this video.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.